You've spent years mastering your craft. Python, JavaScript, Java, you're a solid developer. You can build things. So why does it feel like the goalpost just moved 100 miles down the field overnight? Why are job postings that used to just say software engineer now demanding experience with a whole alphabet soup of services? S3, EC2, Lambda, RDS, DynamoDB? You see junior developers fresh out of bootcamp landing interviews for senior roles simply because they have AWS certified on their LinkedIn profile, and it's infuriating. You feel like you're being left behind not because you're a bad developer, but because you missed a memo that everyone else seems to have gotten. Let me tell you right now, you are not alone. This feeling is sweeping through the developer community across the entire United States, from Silicon Valley to the Silicon Prairie. It's a silent panic that's not just about learning a new tool. It's a fundamental shift in what it means to be a developer in the 2020s. And the memo you missed? It wasn't about a new framework. It was about the end of an era. The era of just writing code that runs on a computer somewhere is over. We are now in the age of the cloud, and Amazon Web Services, or AWS, isn't just leading the charge, it's basically building the stadium where the entire game is now being played. This isn't going to be another mind-numbing tutorial on how to launch a virtual server. You can find 1,000 of those. Instead, over the next few minutes, we are going to pull back the curtain on the real reasons why this shift is happening at lightning speed. This is about strategy, not just syntax. I'm going to show you the 3 powerful economic and technological forces that are pushing nearly every company in America, from Netflix and Airbnb to the corner startup, onto the AWS cloud. More importantly, I'm going to show you why your existing development skills are not obsolete. In fact, they are your secret weapon. When you combine your coding expertise with a strategic understanding of the cloud, you don't just become relevant again. You become unstoppable. You'll understand why this isn't about becoming a cloud engineer. It's about becoming a modern developer who can build, deploy, and scale applications that solve real-world business problems. So if you're tired of feeling like you're one step behind, stick with me. Because by the end of this, you won't just know what AWS is. You'll understand why it's the single most important career skill for a US developer to learn right now. To really get it, we need to rewind the clock. Let's go back just 15 years. Imagine you're a developer, let's call you Alex, working at a promising e-commerce startup in Austin, Texas. You're talented, you're ambitious, and you've just been tasked with building a new feature for the company's website. A personalized recommendations engine. You're excited. This is your chance to make a real impact. But before you can write a single line of code for the feature itself, you have to get a server. So you fill out a procurement form. You send it to your manager, who sends it to the director, who sends it to the IT department. The IT department then has to figure out the specs, how much RAM, how many CPU cores, how much storage. They place an order with Dell or HP. Weeks go by. The server finally arrives in a giant cardboard box. A technician has to wheel it into the server room. That cold, loud room in the basement that always smells faintly of ozone. He has to rack it, connect the power, plug in the network cables. Then an operating system needs to be installed. The network needs to be configured. Security patches have to be applied. A database like MySQL needs to be installed and hardened. It's been a month, a full month. And you, Alex the developer, still haven't written a line of code for the feature you were hired to build. Your job has been to wait. Your company's great idea is sitting on a shelf, collecting dust, waiting for a piece of metal in a cold room to be ready. This wasn't a nightmare scenario. This was normal. This was just how software was built. Companies had to spend hundreds of thousands, if not millions, of dollars on physical hardware before they even knew if their product would be successful. They were making a massive bet on their own predictions. And the biggest problem? Traffic. Let's say your e-commerce site is preparing for Black Friday. You know you're going to get a massive surge of visitors. So what do? You buy 10 extra servers. You spend a fortune on hardware that will be running at 100% capacity for maybe 12 hours a year. For the other 364.5 days, those expensive power-guzzling machines sit there, mostly idle, costing the company money every single second. It was like buying a whole fleet of buses just to handle the rush hour commute, and then having them sit in a parking lot empty for the rest of the day. It was incredibly inefficient, incredibly expensive, and painfully slow. Every developer from that era has war stories about a server's hard drive failing at 3 a.m., or a power supply blowing, and having to drive into the office to physically fix a piece of hardware. The line between being a software developer and a hardware janitor was blurry, to say the least. Now let's fast forward. It's today. And our developer Alex is still at the same company, but things are different. The server room in the basement is gone. It's a game room now with a ping pong table. Alex gets the same task. Build a new personalized recommendations engine. This time Alex opens a laptop, logs into a web page, the AWS Management Console, and with a few clicks provisions a virtual server. Not in a month, not in a week, in about 60 seconds. It's called an EC2 instance, and it's a complete, powerful virtual machine living in one of Amazon's massive, secure data centers. Alex can choose the exact amount of CPU and RAM needed. Need more power? Few clicks. Need less? Few clicks. The entire month-long, soul-crushing procurement process has been compressed into the time it takes to make a cup of coffee. But it gets so much better. Alex needs a place to store product images. Instead of worrying about buying and managing massive, expensive hard drives, Alex uses a service called S3, or Simple Storage Service. It's essentially an infinite hard drive in the sky. It's ridiculously cheap, massively durable, and you pay only for what you use down to the gigabyte. Then there's the database. Instead of the nightmare of installing, patching, backing up, and securing a MySQL database on a server, Alex uses RDS, the Relational Database Service. With a few clicks, a fully managed, production-ready database is up and running. AWS handles the backups, the security patches, the failovers. Alex doesn't have to wake up at 3 a.m. because a database server crashed. Amazon's engineers, some of the best in the world, are doing it for them. Now think about that Black Friday problem, the massive traffic spike. In the old world, you bought 10 extra servers that sat idle all year. In the AWS world, Alex sets up something called an auto-scaling group. Alex defines a rule. If the CPU usage on our web servers goes above 70%, automatically launch new ones. When the traffic dies down after the sale, and CPU usage drops below, say 30%, automatically shut those extra servers down. Think about how profound that is. The infrastructure now breathes. It expands and contracts dynamically with customer demand. You pay for the exact computing power you need when you need it, and not a penny more. The fleet of buses magically appears right before rush hour and vanishes the second it's over. This isn't just an improvement. It's a complete revolution in the economics of running a technology business. This is the why. This is the core reason so many US developers are flocking to learn AWS. It's because the cloud, and specifically AWS as its market leader, fundamentally changes the job of a developer. It removes the shackles. It eliminates the waiting. It vaporizes the distinction between developer and hardware janitor. For decades, developers were forced to spend a huge portion of their time and mental energy on problems that had nothing to do with creating value. They were worried about rack space and cooling and network switches and hard drive failures. AWS abstracts all of that away. It says to the developer, stop worrying about the blinking lights in the basement. We've got that covered. We have built the most reliable, scalable, and secure infrastructure on the planet. You just focus on one thing: writing amazing code that solves your customers' problems. This shift creates a massive leverage point for a developer's career. When you understand how to use these AWS building blocks, EC2 for compute, S3 for storage, RDS for databases, and hundreds of others, you are no longer just a coder. You become an architect. You become a problem solver on a whole new level. You can design and deploy systems that are more resilient, more scalable, and more cost-effective than what was possible for even the biggest corporations just 15 years ago. A single developer, armed with a laptop and an AWS account, can now build and deploy an application with global reach, something that would have previously required a team of dozens and a multi-million-dollar budget. This is why companies are desperate for developers with these skills. A developer who just knows Python or JavaScript is valuable, but a developer who knows Python and knows how to deploy it on a scalable serverless AWS Lambda function, connected to a managed DynamoDB database, with an API gateway front end, that developer is a force multiplier. They can move faster, build bigger, and operate more efficiently. They are the ones who can turn an idea into a global product in a weekend. They are the ones who are getting the promotions, leading the teams, and commanding the highest salaries. So the explosion in demand for AWS skills isn't a fad. It's not just another framework of the month. It's a response to a fundamental tectonic shift in how technology is built and delivered in the United States and across the world. Learning AWS isn't about learning a brand name. It's about learning the new language of infrastructure. It's about learning how to build for speed, for scale, and for the future. It's the difference between being a carpenter who only knows how to use a handsaw and one who has mastered a full workshop of power tools. Both can build a house, but one is going to do it faster, better, and be in much higher demand. We've seen the before and after picture from 30,000 feet. We understand the strategic why. Now it's time to zoom in. It's time to get our hands dirty and look at the actual power tools themselves. Because while AWS offers over 200 services, a developer's journey almost always starts with the foundational trinity, the three core services that power a huge percentage of the internet as we know it: EC2, S3, and RDS. Compute, storage, and database. To put it in a human analogy, it's the brain, the attic, and the memory. This is the holy trinity of cloud infrastructure. And understanding these three services is like learning the three primary colors of the digital world. Once you master them, you can paint almost any picture you can imagine. Let's start with the brain, EC2. It stands for Elastic Compute Cloud. And that one word, elastic, is what changed the entire game. In the old world, if you wanted to run a website, you had to buy a physical computer, a server. You'd guess how much power you needed, probably overestimate to be safe, and spend thousands of dollars on a big metal box. You'd stick it in a cold room and pray it never broke. And for 95% of the day, that expensive box would be sitting there barely breaking a sweat, using just a fraction of its power. But you paid for all of it 24/7. It was like buying an entire 18-wheeler truck just to get your groceries once a week. Inefficient doesn't even begin to cover it. EC2 flipped that entire model on its head. It said, don't buy the truck. Just rent a vehicle by the second, and only pay for exactly what you need when you need it. EC2 lets you rent virtual computers in Amazon's massive data centers. You can choose the size, from a tiny machine less powerful than your phone, to a monster with more processing power than a Hollywood animation studio. You can spin one up in minutes and you can turn it off just as fast. But here's the elastic magic. Imagine you launch a new social media app. On day one, you have 100 users. A single small EC2 instance handles the traffic just fine. You're paying maybe a few bucks a day. Then, a celebrity tweets about your app. Suddenly, you don't have 100 users. You have 100,000 users hitting your site at the same time. In the old world, your single server would melt. The website would crash. You're one shot at fame and fortune, gone in a puff of smoke, and a 503 service unavailable error. With EC2, you can set it up to be elastic. It can automatically detect the massive traffic spike, and within minutes, clone itself. It can spin up 10, 50, 100 identical copies of your server to handle the load. Millions of requests are being served, your new users are having a great experience, and your app is a roaring success. Then at 3 a.m. when the traffic dies down, EC2 automatically shuts down all those extra copies. You stop paying for them instantly. This single concept, paying only for the compute power you actually use and being able to scale near infinitely on demand, is the engine that powers the entire modern startup ecosystem. It gives a two-person team in a garage the same firepower that used to be reserved for Fortune 500 companies. For a developer, this is freedom. It's the freedom to experiment, to launch, to dream big without needing $1 million in venture capital just to buy hardware. So, EC2 is the brain running your code and doing the thinking. But where does it store things? That brings us to the second member of the Trinity, S3, the Infinite Attic. S3 stands for Simple Storage Service, and it's one of the most deceptively powerful services on the planet. On the surface, it's just a place to put files. But it's not like a hard drive. It's a completely different beast. First, it is, for all practical purposes, infinite. You never have to worry about running out of space. You just put files in and it expands forever. Netflix, one of the biggest users of AWS, stores its entire petabyte-scale library of movies and TV shows on S3. Every photo you see on Airbnb, it's sitting in S3. Second, it's unbelievably durable. Amazon designed S3 for what they call 11 nines of durability. That's 99.999999999%. What does that even mean? It means if you stored 10 million files in S3, you could expect to lose maybe one of them every 10,000 years. Your data is safer in S3 than it is on any physical hard drive you will ever own. Amazon achieves this by automatically making copies of your data and storing them in multiple different physical locations. If one data center gets hit by a meteor, your data is still safe somewhere else. And finally, it's dirt cheap. We're talking about a few pennies per gigabyte per month. It's so cheap it's almost free for small projects. This combination, infinite scale, military-grade durability, and bargain basement pricing, made S3 the default storage layer for the internet. Developers use it for everything: storing user profile pictures, hosting the images and videos for a website, keeping backups, archiving log files, distributing software. It's the ultimate digital warehouse. So we have the Brain EC2 and the Infinite Attic S3, but we're missing a crucial piece: the short-term and long-term memory, the place for structured, organized information. That's where the third service comes in: RDS, the Relational Database Service. Every meaningful application needs a database. It's where you store user accounts, product catalogs, blog posts, financial records, anything that needs to be organized, searched, and updated quickly. For decades, the workhorses of this world have been relational databases like MySQL and PostgreSQL. They are powerful, reliable, and a massive pain to manage yourself. Running a production database is a high-stakes, high-stress job. You have to worry about installing it, configuring it for performance, patching it for security vulnerabilities, performing backups every night, and having a plan to recover if the hardware fails. This is the job of a database administrator, or DBA, a highly specialized and expensive role. RDS is Amazon's solution. It says to developers, you focus on building your app. We'll be your world-class 24/7 DBA team. With RDS, you don't manage a database server. You just use a database service. In the AWS console, you can say, I want a PostgreSQL database. Make it this powerful. Automatically back it up every day. And please create a live, standby copy in a different data center so if the main one fails, you can switch over automatically in under a minute. You click a button and a few minutes later it's done. All that complexity, the patching, the backups, the high availability failover, is completely managed by Amazon. This is a force multiplier for developers. It allows a single engineer to wield the power of an entire IT department. It removes one of the biggest and most dangerous single points of failure for any application and turns it into a reliable, managed utility, like electricity from the wall socket. You don't build your own power plant. You just plug in. You don't manage your own database server. You just connect to RDS. So let's put the Trinity together. Let's imagine a simple photo sharing app. The application code itself, the logic that handles logins and likes and comments, runs on an EC2 instance. That's the brain. When a user uploads a new photo, that image file isn't stored on the EC2 server. No, it's sent directly to S3, our Infinite Attic. The EC2 brain just keeps a reference to it. And all the metadata, the user's name, the photo's caption, the number of likes, the comments, that structured data is stored in our managed RDS database, the application's memory. A user visits the site. Their browser sends a request to your EC2 instance. The EC2 brain queries the RDS memory to get the photo caption and comments. It then fetches the actual image file from the S3 Attic and assembles it all into a web page that it sends back to the user. Brain, Attic, Memory, EC2, S3, RDS. This simple three-part pattern is the fundamental architecture for a staggering number of applications on the internet today. It's scalable, it's durable, and it's cost-effective. Learning this trinity is the first major step into the world of cloud development. It's the foundation upon which everything else is built. But knowing what these building blocks are is one thing. The real revolution, the thing that truly turned developers into masters of their own universe, wasn't just having access to these tools through a web browser. It was the ability to command and control this entire symphony of services not with clicks but with code. And that brings us to one of the most powerful ideas in modern software: infrastructure as code. Infrastructure as code. This isn't just a buzzword. It's a fundamental paradigm shift that turned the chaotic art of system administration into a disciplined, predictable engineering practice. Before this idea took hold, setting up a new server or an entire environment for an application was a manual, error-prone nightmare. An engineer would log into a console, click through dozens of screens, follow a dusty, outdated Word document checklist, and pray they didn't miss a step. Every server became a unique, fragile creation. We called them pets. You gave them a name like Zeus or Apollo. You nursed them when they were sick. And if one of them died, it was a catastrophe. Why? Because nobody, not even the person who built it 6 months ago, could remember the exact combination of clicks, commands, and configuration tweaks that made it work. These were snowflake servers, each one a unique and terrifying mystery. Trying to create a second, identical server for testing was nearly impossible. You'd inevitably miss one tiny setting, and then spend weeks chasing down bizarre bugs that only happened in the production environment. This manual process was slow, it was risky, and it absolutely could not scale. Infrastructure as Code, or IAC, flips this entire model on its head. The core principle is simple. You manage and provision your entire IT infrastructure, your servers, your databases, your networks, your firewalls, everything, through machine-readable definition files. You don't click buttons anymore. You write code. Think of it like this. The old way was like building a complex Lego model with no instructions, just a vague memory of how you did it last time. The new way, the IAC way, is having a precise step-by-step blueprint. A blueprint that anyone can read, and more importantly, a machine can read and execute flawlessly every single time. In the AWS world, the primary tool for this is called AWS Cloud Formation. With Cloud Formation, you define all your AWS resources in a text file, a template written in either YAML or JSON. You want a web server? You describe its size, its operating system, its security rules right there in the file. You need a database? You define its engine, its storage capacity, and its backup policy. You need them to be able to talk to each other over a private network? You define that network, the subnets, the route tables, all in that same text file. You then hand this template to AWS. Cloud Formation reads your blueprint and acts as your master builder. It goes out and provisions every single resource in the right order, configuring everything exactly as you specified. And when it's done, you have a perfectly constructed, fully functional environment. They call this collection of resources a stack. This is where the superpowers for developers begin to emerge. First, repeatability. Because your entire environment is defined in a file, you can now create identical copies of it on demand. Need a staging environment to test a new feature? Run the template. Need a temporary environment for a quality assurance team? Run the template. Need to deploy your application to a brand new geographic region in Europe because your company is expanding? Change a single region parameter and run the template. Every environment is a perfect clone of the other, eliminating the entire category of "it works on my machine" bugs that used to plague development teams. The snowflake servers are gone. Instead of pets that you have to care for, your servers become cattle. They are identical, disposable resources. If one gets sick, you don't try to fix it. You terminate it, and you spin up a new, perfectly healthy one from the template in minutes. Second, and this is the one that really makes developers' eyes light up, is version control. Because your infrastructure is now just a text file, you can treat it exactly like you treat your application code. You can check it into a source control system like Git. And this changes everything. You now have a complete, auditable history of every single change ever made to your infrastructure. Who added a new firewall rule? When did they do it? And why? The answers are right there in the Git log. You can see the commit message. Want to make a change? You don't just log in and start clicking. You create a new branch, you modify the Cloud Formation template, and you submit a pull request. Your teammates can then review the proposed infrastructure change, comment on it, and approve it before it ever gets deployed. It brings the same rigor, collaboration, and safety of a software development workflow to the world of infrastructure. If a change you deploy ends up causing a problem, rolling back is as simple as reverting the commit and rerunning the template. The system automatically figures out what changed and returns your infrastructure to its last known good state. This is an incredible safety net. Third, automation and scalability. The manual process of setting up infrastructure was a bottleneck. With IAC, it's an API call. This means you can automate everything. You can build systems that automatically scale your infrastructure based on demand. Imagine it's Black Friday, and traffic to your e-commerce site is exploding. Instead of a frantic all-hands-on-deck emergency, you can have a system that detects the increased load and automatically updates your Cloud Formation stack, changing the desired number of web servers from, say, 10 to 100. Cloud Formation handles the rest, provisioning the 90 new servers, configuring them, and adding them to the load balancer, all without any human intervention. When traffic dies down, it automatically scales back in, saving you money. This elasticity is the promise of the cloud, and infrastructure as code is the mechanism that unlocks it. This shift has profoundly changed the role of the developer. They are no longer just responsible for the application. They are now empowered to define and control the entire environment in which it runs. This is the essence of the DevOps movement, breaking down the walls between development and operations. A developer can now write the code for a new microservice, and in the very same project, write the IAC template that defines the exact database, server, and network configuration that service needs to run. They own the entire lifecycle from code to production. This level of ownership and control is incredibly powerful, and it's a skill that is in ridiculously high demand. Now, while CloudFormation is the native AWS solution, it's important to mention that the concept of IAC is bigger than any single tool. Another immensely popular tool in this space is Terraform, by a company called HashiCorp. Terraform does largely the same thing. It lets you define infrastructure as code, but with one key difference. It's cloud agnostic. You can use it to manage resources not just in AWS, but also in Google Cloud, Microsoft Azure, and others, all from the same configuration files. For companies that have a multi-cloud strategy, Terraform is often the go-to choice. But for teams that are all in on AWS, CloudFormation offers deeper, more seamless integration with the rest of the AWS ecosystem. For a developer, learning either of these tools is like learning to see the matrix. You stop seeing a bunch of disparate services and start seeing a single unified system that can be shaped, molded, and controlled with code. You gain the ability to build, replicate, and destroy entire digital worlds with a few keystrokes. It's an intoxicating level of power and control. So now you have this perfect, version-controlled, automated factory for creating your application's environment. The factory floor is pristine, the machinery is state-of-the-art, and you can build a new assembly line at a moment's notice. But this raises the next critical question. How do you actually get your product, your application code, onto that assembly line? And how do you do it safely and efficiently, not just once but potentially hundreds of times a day? This is where the magic of automated deployment pipelines and containerization comes in. This is the fundamental problem of modern software development. It's no longer enough to just write code. You have to be an expert in delivering it. And for decades, this delivery process was a nightmare. It was a dark art, a ritual filled with manual steps, crossed fingers, and a whole lot of prayer. We called it deployment day, and we dreaded it. Imagine this. It's 10 p.m. on a Friday. Why Friday? Because if you break everything, you have the whole weekend to fix it before the boss notices on Monday. The entire development team is huddled in an office, surrounded by cold pizza boxes and empty energy drink cans. One person, the designated deployer, has a 20-page document open, a checklist of manual steps. Step 1. Use an FTP client to manually upload the new code files to the production server. You drag and drop, hoping the connection doesn't time out, and leave the site in a half-updated, broken state. Step 2. SSH into the server. That's a remote terminal, a black screen with a blinking cursor. You start typing arcane commands to stop the web server, copy the new files into place, and restart it. Your heart is pounding in your chest because one typo, just one misplaced character, could wipe out the entire application. Then comes the inevitable moment of truth. Someone says, "It's not working. The site is down." Panic sets in, and then the blame game begins. The developer says, "Well, it worked on my machine." And this right here was the single most frustrating phrase in software history. And it was true. It did work on his laptop. Why? Because his laptop had a different version of the operating system. It had a different version of a critical software library. It had a configuration file that he forgot to copy over. The developer's machine was a unique, handcrafted environment, and the production server was a completely different beast. The two were worlds apart. Trying to make code that worked in one place work in the other was like trying to run a video game designed for a PlayStation on an Xbox. It just wasn't going to happen without a lot of pain. This entire process was slow, it was terrifying, and it was unbelievably risky. Companies could only afford to do it once a month, maybe once a quarter. Innovation crawled at a snail's pace, shackled by the fear of deployment. This was the world before the cloud, and it was broken. Then, a revolutionary idea changed everything. It started with a simple metaphor: a shipping container. Think about global trade before the standardized shipping container. You had barrels of wine, sacks of coffee, crates of electronics, all different shapes and sizes. Loading and unloading a ship was a chaotic, inefficient, and time-consuming puzzle. Then the standardized steel box was invented. Suddenly, it didn't matter what was inside. A container of coffee was handled exactly the same way as a container of car parts. It could be moved seamlessly from a truck to a train to a ship because the interface, the container itself, was standard. This is exactly what Docker and containerization did for software. A developer, instead of just shipping their code, packages their application and all of its dependencies, the specific version of the programming language, the libraries, the system tools, everything into a single standardized sealed unit called a container. It's a perfect, self-contained little box that has everything the application needs to run frozen in time. The "it works on my machine" problem? Gone. Instantly. Because you're no longer just shipping the code, you're shipping the entire machine environment along with it. That container will run identically on the developer's Mac, on a testing server in the office, and on a massive AWS server in the cloud. The underlying hardware and operating system no longer matter as much, because the application is living inside its own consistent, predictable bubble. This was the aha moment for the entire industry, but it created a new, high-quality problem. Okay, great, we now have these perfect little software boxes, but a real-world application isn't just one box. It's a fleet of them. You might have 10 containers for your website, 5 for your user database, 3 for your payment processing system. You need them to talk to each other. You need to be able to scale up from 10 website containers to 1,000 during a traffic spike, and then scale back down to save money. You need to automatically replace any container that crashes. You need to manage this entire fleet. You need an orchestrator, a port authority for your software containers. And this is where developers learning AWS strike absolute gold. Because AWS provides the world's best platforms for running and orchestrating containers at scale. The first and simplest is Amazon ECS, the Elastic Container Service. This is AWS' own, highly integrated system. It's the fastest way to get your containers up and running in the cloud. It's powerful, it's straightforward, and it's deeply woven into the fabric of other AWS services. But then there's the undisputed king of the container world, Kubernetes. Kubernetes is an open-source project originally designed by Google, and it has become the de facto operating system for the cloud. It's an astonishingly powerful, but notoriously complex piece of technology. Running your own Kubernetes cluster used to be a full-time job for a team of specialists. So what did AWS do? They created Amazon EKS, the Elastic Kubernetes Service. EKS gives you all the power, all the flexibility, all the industry-standard compatibility of Kubernetes, but AWS manages the brutal complexity of the underlying control system for you. Developers get the best of both worlds. And if that wasn't enough, AWS took it one step further with a service that feels like pure science fiction. AWS Fargate. With ECS and EKS, you still have to think a little bit about the underlying EC2 servers that your containers are running on. You have to provision them, manage them, patch them. Fargate says, forget all that. Just give us your container. Tell us how much CPU and memory it needs. We'll handle the rest. You never see a server. You never manage an operating system. It is the ultimate expression of serverless containers. You pay only for the resources your container actually consumes by the second. For a developer, this is nirvana. It's the purest way to run your code. You build your container, hand it to Fargate, and it just runs at any scale. So we have the perfect package, the container, and we have the perfect place to run it, ECS, EKS, or Fargate. Now we need to build the factory, the automated assembly line that takes a developer's raw code and turns it into a container running in production, safely and repeatedly. This is the world of CI/CD, or continuous integration and continuous deployment. And AWS provides the tools to build the most sophisticated software assembly lines on the planet. It starts with AWS Code Commit, which is a private, secure place to store your code just like GitHub. When a developer pushes a change, it triggers the start of the assembly line, which is orchestrated by AWS Code Pipeline. Code Pipeline is the factory manager. It defines the stages: first build, then test, then deploy to a staging environment, finally deploy to production. For the build stage, Code Pipeline calls on AWS Code Build. Code Build is like a temporary superpowered computer that spins up, pulls down your code, runs all the commands to compile it, and most importantly builds that Docker container image we talked about. It then pushes that finished, sealed container image to a storage locker called the Amazon Elastic Container Registry, or ECR. Next, the test stage. Code Pipeline can trigger another code build job to run thousands of automated tests against that new container image. Does the login page still work? Can users add items to their cart? Does it perform well under load? If any single test fails, the pipeline stops. The defective code is rejected before it ever gets near a real user. The factory's quality control has kicked in, but if it all passes, Code Pipeline moves to the final stage, calling on AWS Code Deploy. Code Deploy is the master of safely releasing new software. It can perform advanced deployment strategies that were once unthinkable. It can do a blue/green deployment, where it builds up an entire new copy of your production environment with the new code, and then in an instant switches all user traffic over. If there's a problem, it can switch back just as instantly. Or it can do a canary deployment, sending just 1% of your users to the new version, monitoring for errors, then gradually rolling it out to 10%, 50%, and finally 100%. Think back to that Friday night pizza party. The terror, the manual steps, the risk. Now picture this. A developer on a Tuesday morning changes one line of code on her laptop and clicks push. Within minutes, AWS Cloud Pipeline has automatically built it, tested it, and deployed it to millions of users with zero downtime, using a safe, automated canary release. The developer didn't run a single command on a server. She just wrote code. The AWS-powered factory did the rest. This isn't a fantasy. This is how elite tech companies operate every single day. And it's a skill that is in white-hot demand. They need developers who don't just write code, but understand how to build the machine that delivers that code. We've now designed a truly modern, world-class software factory. We have the raw materials, the infrastructure from EC2 and S3. We have the automated assembly line, the CI/CD pipeline and container orchestration. But every factory, every application produces something. It produces data. And in the modern world, data is the most valuable resource of all. How do you store it, manage it, and query it at a global scale? How do you choose the right tool, the right database for the right job? Because that choice can be the difference between a billion-dollar success and a catastrophic failure. This is the single most important architectural decision you will ever make. It's the foundation upon which your entire application rests. And in the old world, the on-premise world, the choice was deceptively simple. You'd pick one big, powerful, expensive database server, maybe an Oracle box, maybe a huge SQL Server instance, and you'd cram everything into it. User data, product catalogs, session information, logs, analytics, everything. It was the digital equivalent of throwing all your clothes, your tools, your kitchen utensils, and your family photos into one giant monolithic closet. For a while it works. It's simple. But then success becomes your worst enemy. Imagine you're the lead developer at a hot new e-commerce startup. Your app is slick, your marketing is brilliant, and one morning you wake up to find you've been featured on Good Morning America. The floodgates open. A tsunami of traffic hits your site. And that one giant database, your single source of truth, starts to creak. Then it groans. Then it falls over. Your site goes down. Every second of downtime costs you thousands of dollars in lost sales and, even worse, reputational damage. You and your team are in a frantic all-hands-on-deck war room, trying to reboot the server, optimize queries on the fly, and pray it holds. This isn't a hypothetical. This was the reality for a generation of developers. The very architecture that enabled their initial growth became a concrete ceiling, preventing them from ever reaching the next level. This is where the cloud, and specifically AWS, completely rewrites the rulebook. The fundamental paradigm shift isn't just about renting servers. It's about moving away from that one giant closet model to something infinitely more powerful, the idea of purpose-built databases. The philosophy is simple, yet revolutionary. Don't try to force a single database to do everything. Instead, use the absolute best tool for each specific job. AWS doesn't just offer you a database. It offers you a portfolio of over 15 different purpose-built database engines, each one engineered to solve a specific kind of problem with breathtaking efficiency. And this is the secret weapon that developers are flocking to learn. Let's start with the familiar. Most applications start life with a relational database. Think neat rows and columns like a spreadsheet. This is perfect for things with a rigid structure, like a user table with columns for name, email, and password, or an orders table. For this, developers have long-loved open-source engines like MySQL and PostgreSQL. So, does AWS force you to abandon these? Absolutely not. It supercharges them with a service called Amazon RDS, the relational database service. This is the first major aha moment for so many developers. RDS takes away the single biggest headache of running a database: the administration. All the stuff that developers hate, provisioning the hardware, patching the operating system, installing the database software, performing backups, it all just vanishes. It's managed for you. But the real magic is what it does for reliability. Remember our startup whose site went down? With RDS, you can click a single checkbox called Multi-AZ for Multi-Availability Zone. Instantly, AWS creates a perfect, live, synchronous replica of your entire database in a completely separate, physically isolated data center miles away. If your primary database ever fails, if the server crashes, if a network card dies, if a construction worker accidentally cuts a fiber optic cable to the entire data center, RDS automatically fails over to the standby replica in under a minute with zero data loss. Your application just keeps running. The customer buying a pair of shoes never even notices. For a developer who has lived through a 3 a.m. database crash, this capability alone feels like pure science fiction. But AWS didn't stop there. They looked at the core architecture of traditional databases like MySQL and PostgreSQL and said, we can do better. The result is Amazon Aurora. If RDS is MySQL on easy mode, Aurora is MySQL on God mode. It's a complete ground-up reimagining of what a relational database can be in the cloud. Aurora separates the compute part of the database, the part that runs the queries, from the storage part. This is a game changer. The storage layer is this incredible, self-healing, fault-tolerant system spread across 3 availability zones. Your data is automatically written 6 times. 6 copies. It can lose up to 2 copies of your data without affecting your ability to write, and up to 3 copies without affecting your ability to read. It's designed for 99.99% availability. Performance is staggering, up to 5 times the throughput of standard MySQL, and 3 times that of standard PostgreSQL. For developers, this means they can handle massive workloads without the complexity and astronomical cost of traditional commercial databases. This is already a revolution, but it's only half the story. The real power comes when you realize that not all data fits neatly into rows and columns. What about the data that powers modern, fast-moving applications? A user's shopping cart, the contents of a social media feed, a product catalog where different products have wildly different attributes. Trying to shoehorn this kind of flexible, semi-structured data into a rigid relational model is painful. It's slow, it's brittle, and it's a nightmare to change. This is why developers are so excited about NoSQL databases. An AWS flagship offering here is DynamoDB. DynamoDB is a key value and document database that delivers single-digit millisecond performance at literally any scale. Let that sink in. Not it's fast for 1,000 users. Not it's fast for 1,000,000 users. It delivers the same predictable, low-latency performance whether you have 1 user or 1 billion users. It is, for all practical purposes, infinitely scalable. Think of it like the valet key system at a massive hotel. Your key is the partition key, say a user ID. When you give that key to DynamoDB, it doesn't have to search through a giant table. It knows exactly where to go to retrieve the value. The user's entire profile, stored as a flexible JSON document. This is how companies like Amazon itself can power their shopping cart. Every single one of the hundreds of millions of active Amazon.com customers has a shopping cart. When you click Add to Cart, the response has to be instantaneous. That's DynamoDB. It's the engine behind Lyft's backend, matching millions of riders with drivers. It's the workhorse for Disney+, storing user activity and metadata for its massive streaming platform. For a developer building a modern, global-scale application, learning DynamoDB isn't just an option, it's a necessity. It unlocks a level of performance and scale that was previously unimaginable. So now you have a choice. For your structured transactional data, you have the rock-solid supercharged power of Aurora. For your high-velocity, flexible, massive-scale data, you have the limitless potential of DynamoDB. And AWS offers even more specialized tools. Need to work with graph data, like for a social network or a recommendation engine? There's Amazon Neptune. Need a database for time series data, like from IoT sensors or financial tickers? There's Amazon TimeStream. This is the core of the modern cloud developer's toolkit. It's a shift from being a SQL developer to being a data architect. You're no longer just managing one giant closet. You're designing a perfectly organized home. You have a closet for your clothes, Aurora, a high-speed pantry for your everyday items, DynamoDB, a safe for your valuables, and a garage for your big projects. Each piece of data lives in the exact right place, optimized for performance, scale, and cost. This approach, sometimes called polyglot persistence, is the blueprint for building resilient, world-class applications. It allows a developer to stop fighting their database and start leveraging it as a strategic advantage. But this raises a new, profound question. If your data is now living in all these different specialized systems, how do you make sense of it all? How do you query across them? How do you take the user data from Aurora, combine it with the clickstream data from DynamoDB, and mix it with the server logs you're storing somewhere else to get deep, meaningful business insights? You've solved the problem of storing and serving data for your application, but you've just created a brand new, even bigger challenge: analytics at scale. This is where the dream of a simple, elegant application collides with the messy, brutal reality of a successful business. Because data in its raw form isn't insight. It's noise. It's a liability. It's millions of log files, terabytes of user events, and endless streams of clicks and transactions, all sitting in separate digital buckets, completely unaware of each other. The question that keeps CEOs and product managers awake at night is how to fuse all that noise into a single coherent signal. How do you turn raw data into decisions? For decades, the answer was a painful, expensive, and soul-crushingly slow process called ETL. Extract, transform, and load. This was the dark art of the data world. You'd have an army of specialized engineers writing brittle, custom scripts. First, they'd extract data from your production database. Then they'd transform it, cleaning it, reshaping it, forcing it into a rigid, predefined structure. This step was a minefield. A single unexpected character or a slightly changed format in the source data could cause the entire pipeline to shatter, leading to late-night emergency calls and days of painstaking debugging. Finally, if you were lucky, the script would load the processed data into a monstrously expensive on-premises data warehouse. These weren't just servers. They were monolithic beasts from companies like Teradata, Oracle, or Netezza. They cost millions of dollars in upfront hardware and licensing fees. They required a dedicated team of administrators, often called database administrators or DBAs, who were the sole gatekeepers to this precious data. If you, a humble developer, wanted to run a query, you'd have to file a ticket and wait. If you wanted to add a new data source, say track a new button click on your website, it could trigger a 6-month project to remodel the entire data warehouse schema. The system was designed for stability, not agility. It was a fortress built to protect the data, but it was so well fortified that getting any value out of it was a siege. This created a two-tiered system in tech. You had the application developers who moved fast and built the product, and you had the data engineers who moved slow and guarded the single source of truth. The two worlds barely spoke the same language, and the friction between them slowed innovation to a crawl. This is the world that AWS completely dismantled. And it started with a service we've already talked about, S3. Developers who are new to the cloud often see S3 as just a place to store files, a giant cheap hard drive in the sky. But that's like saying a smartphone is just a device for making calls. The true power of S3 is that it's the foundation of a revolutionary concept: the data lake. Forget the rigid, structured, and expensive data warehouse for a moment. A data lake has a simple, beautiful premise. Put all of your data, from every single source, into one centralized place, in its raw native format. Your structured user data from RDS? Dump it in S3. Your semi-structured JSON logs from your application servers? Dump them in S3. The unstructured images and videos uploaded by users? They're already in S3. CSV files from your marketing team's analytics platform? Put them in S3. There's no need to define a schema upfront. There's no expensive transformation process before you can even store it. The motto is, store everything now, figure out how to analyze it later. This single idea shatters the biggest bottleneck of the old world. It decouples the act of data collection from the act of data analysis. But now you have a new problem. You've got a data swamp, a vast, disorganized repository of files in a dozen different formats. How on earth do you make sense of it? This is where the second piece of the AWS puzzle comes in, a service called AWS Glue. Glue is a fully managed, serverless ETL service. But its most magical feature is the Glue Data Catalog. You can point Glue at your S3 data lake, and its crawlers will automatically scan your files. They'll read your Parquet files, your JSON files, your CSVs, and they will infer the schema automatically. It figures out the column names, the data types, and the structure of your data, and it creates a single unified metadata repository, a master index for your entire data lake. Think about what this means. You've eliminated the most painful, manual, and error-prone part of the old ETL process. You don't need to write complex scripts just to understand the shape of your data. Glue does it for you, and it keeps the catalog updated as new data arrives. It's like having a brilliant, tireless librarian who instantly reads every book you throw into your library, understands its contents, and creates a perfect card catalog for you in real time. Okay, so you have all your data in one place, and you have a catalog that tells you what's in it. Now, how do you ask questions? How do you query it? This brings us to the third, and perhaps most mind-blowing, service in the AWS data stack: Amazon Athena. Athena is a serverless, interactive query service. And here's the killer feature. It lets you use standard SQL to query your data directly in S3. Let me repeat that because it's a radical departure from everything that came before. You don't have to load the data into a database. You don't have to spin up any servers. You don't have to provision any clusters. You open the Athena console, you write a standard SQL query referencing the tables in your Glue data catalog, and you hit run. Behind the scenes, Athena marshals a massive amount of parallel computing power, scans the relevant data in your S3 bucket, executes your query, and returns the results in seconds. And you only pay for the data you scan. If you don't run any queries, you pay nothing. Imagine the power this gives a developer. You can now write a single SQL query that joins your user profile data, stored as JSON, with your web server access logs stored as CSV, and your product inventory data stored as Parquet, and get an answer. A task that would have taken a team of data engineers months to set up in the old world, you can now accomplish on your own in an afternoon. This isn't just an incremental improvement. It's a quantum leap in agility. It democratizes data. Any developer who knows SQL can now be a data analyst. Now, for massive enterprise-scale analytics where you have hundreds of business analysts and data scientists running complex queries all day long, you might need even more performance and concurrency. That's when you graduate to Amazon Redshift, AWS fully managed data warehouse. But even Redshift is a complete reinvention of the old model. It's a columnar database, meaning it's architected from the ground up for blistering fast analytical queries. You can spin up a cluster in minutes, scale it up or down with a few clicks, and pay by the hour. You can start with a cluster for a few $100s a month, not a few $1 million in capital expenditure. And with a feature called Redshift Spectrum, you can even run queries that join the data inside your superfast Redshift cluster with the exabytes of data sitting in your S3 data lake. It gives you the best of both worlds. This is the modern AWS data stack. It's a seamless progression. You start by dumping all your raw data into S3, your data lake. You use AWS Glue to automatically catalog it. You use Athena for ad hoc, serverless exploration and analysis. And when you need dedicated high-performance power for business intelligence, you load the most important data into Redshift. This is why developers are flocking to learn AWS. It's not just about hosting a website anymore. It's about having the power to build a data-driven organization from scratch, using a toolkit that is more powerful, more flexible, and orders of magnitude cheaper than what was available to even the biggest corporations just 10 years ago. It transforms the developer from someone who just writes application code into someone who can generate business insights. You are no longer just building the engine of the car. You now have the keys to the dashboard, the GPS, and the fuel gauge. You can tell the business where it's been, where it is now, and more importantly, you have the raw materials to start predicting where it's going to go next. And that prediction, that leap from historical analysis to future insight, is where the true revolution begins. This leap isn't just about making better guesses. It's about systematically dismantling uncertainty. For decades, business intelligence was like driving a car by only looking in the rearview mirror. You could get incredibly detailed reports about the road you'd already traveled, where the potholes were, the turns you made, the speed you were going. But you were still driving forward into the unknown, relying on gut instinct. What cloud data platforms, and specifically machine learning, have done is bolt a massive high-definition screen onto the windshield that shows you a probable version of the road ahead. The challenge, of course, was that building that screen, that predictive engine, was astronomically difficult. It was the exclusive domain of statisticians with doctorates and giant tech companies with entire research divisions. Creating a machine learning model from scratch required deep, specialized knowledge of linear algebra, calculus, and algorithms, not to mention the massive, expensive infrastructure needed to train the model on huge datasets. For the average developer, it was a completely inaccessible black box. You could use an API from a big company, but you couldn't build your own. And this is where the story takes its most crucial turn. And it's the reason millions of developers are flooding into the AWS ecosystem. The revolution wasn't just about providing the raw computing power. It was about abstracting away the most complex parts of machine learning. It was about turning the arcane art of data science into an engineering discipline. Enter Amazon's SageMaker. If you take one thing away about the why now of AWS, let it be this: SageMaker did for machine learning what the first compilers did for programming. Before compilers, you had to write in assembly language, manually managing memory registers and machine-level instructions. It was painstaking, slow, and reserved for a tiny priesthood of experts. Compilers allow programmers to write in higher-level languages, focusing on logic and function instead of the machine's architecture. It unleashed a torrent of creativity and productivity. SageMaker is that compiler for machine learning. It's a fully managed service that provides developers with the tools to build, train, and deploy machine learning models at any scale, without needing a PhD. It systematically attacks every point of friction in the ML lifecycle. Think about it from a developer's perspective. First, you need data. We've already established how your data is likely sitting in an S3 data lake or a Redshift warehouse. SageMaker plugs directly into that. Step 1 solved. Next, you need to process that data and explore it. SageMaker provides hosted Jupyter notebooks, the de facto standard for data scientists, with a single click. You don't have to set up servers, manage Python environments, or install libraries. You just start coding. Step 2, friction removed. Then comes the hardest part, building and training the model. This is where the magic happens. SageMaker offers dozens of built-in, high-performance algorithms that are already optimized for large-scale datasets. You don't have to write a fraud detection or a customer churn algorithm from scratch. You can pick one off the shelf, feed it your data, and tell it what you want to predict. You're not reinventing the wheel. You're choosing the right set of tires for the terrain you're on. And the training process itself? In the old world, this meant provisioning a fleet of powerful servers, configuring them, and babysitting a training job for days or weeks. In SageMaker, it's literally a single API call. You say, here's my data, here's the algorithm. I need 10 of your most powerful GPU instances, go. SageMaker finds the resources, spins them up, runs the training job, copies the resulting model back to S3, and then, and this is key, it shuts everything down so you stop paying for it. It's the cloud ethos of on-demand resources applied to the most compute-intensive task in modern technology. Finally, you have a trained model. Now what? How do you get it into your application? This used to be another massive headache involving containerization, building APIs, load balancing, and auto-scaling. With SageMaker, it's another single API call. You say, take this model and deploy it as a secure, highly available HTTPS endpoint. Seconds later, you have an API that your application can call to get real-time predictions. Let's make this real. Imagine you're a developer at an e-commerce startup. Your boss says, we need a recommended for you feature, just like Amazon's. 5 years ago, you'd have said it was impossible. Today with AWS, you say, give me a week. You pull the purchase history from Redshift. You use a SageMaker notebook to clean it up. You choose a built-in algorithm like K-nearest neighbors. You train the model on that data. You deploy it as an endpoint. Now your website's code can send a customer's ID to that endpoint, and it gets back a list of product IDs to recommend. You've just implemented a core AI feature that was once the sole province of trillion-dollar companies. This is why developers are learning AWS. It's not just about spinning up servers anymore. It's about being handed a full set of power tools that allow you to build intelligent applications. You can build systems that detect fraudulent transactions in real time. You can build applications that predict which sales leads are most likely to convert, allowing the sales team to focus their efforts. You can analyze customer support tickets to predict which customers are at risk of leaving, so you can intervene proactively. This is a fundamental shift in the role of a developer. You are no longer just a builder of features based on a spec sheet. You are becoming a strategist, armed with data and predictive tools. You are the one who can go to the business and say, I analyzed our user behavior data, and I can build a model that predicts with 85% accuracy which users will stop using our app in the next 30 days. We can use that to offer them a discount and keep them. That conversation is infinitely more valuable than, I finished the button color change ticket. And for developers who don't want to get that deep into the weeds of model training, AWS has gone even one level higher up the abstraction ladder. They offer a suite of AI services that are just pure APIs. You don't manage data or models at all. You just use them. Want to add image recognition to your app? You use Amazon Rekognition. You send it an image, and it sends you back a JSON object with a list of labels. Car, tree, dog, happy. Want to convert an article into an audio podcast? You send the text to Amazon Polly, and it sends you back a human-sounding MP3 file. Want to understand the sentiment of a product review? You send the text to Amazon Comprehend, and it tells you if it's positive, negative, or neutral. This layered approach is genius. It creates an on-ramp for every single developer in the world. Whether you're a data scientist who wants to fine-tune every hyperparameter of a custom neural network, or a front-end developer who just wants to add voice commands to an app, there is a tool waiting for you. This is the economic earthquake that is forcing the entire industry to adapt. Companies are realizing that the data they've been collecting for years isn't just a record of the past. It's the blueprint for their future. And the people who can read that blueprint, who can translate that raw data into predictive power, are the developers. A developer who understands this ecosystem, how data flows from applications into a data lake, how it's analyzed in a warehouse, and how it's used to train and deploy a machine learning model, is not just 10% more valuable. They are 10 times more valuable because they can build products that learn, adapt, and anticipate the future. They can build the moat that protects a business from its competition. We've seen how AWS lets you collect and store data at scale, how it allows you to analyze it for past insights, and now how it empowers you to predict the future. But there's one final massive piece of the puzzle. How do you deliver these applications, these insights, these real-time predictions, to a global user base with the lowest possible latency and the highest possible availability? Building an intelligent application is one thing. Running it for millions of users across continents, with millisecond response times, is a completely different challenge. And that is where the sheer physical scale of AWS global infrastructure comes into play. Think about it like this. Before the cloud, if you were a developer in, say, Chicago, and you built a successful application, your servers would probably be in a data center somewhere nearby. That's great for your users in Illinois, maybe even for users in New York or California. But what happens when your app suddenly gets popular in Germany, or Japan, or Australia? Every request from a user in Frankfurt has to travel across the Atlantic Ocean, hit your server in Chicago, and the response has to travel all the way back. That round trip, even at the speed of light through fiber optic cables, introduces a noticeable delay. We call this latency. And in the digital world, latency is the enemy. A few hundred milliseconds of delay can be the difference between a happy, engaged user and a frustrated customer who closes the tab and never comes back. For decades, solving this problem was astronomically expensive. It meant leasing space in data centers all over the world, buying and managing hardware in multiple countries, dealing with different regulations, and hiring international teams. Only the absolute biggest tech giants could afford to build a truly global infrastructure. This is what AWS has fundamentally changed. When we talk about the physical scale of AWS, we're talking about a planet-spanning network of data centers, organized into what they call regions and availability zones. A region is a physical location in the world where AWS has multiple data centers. For example, there's a major region in Northern Virginia, another in Ohio, one in Oregon, and one in Northern California, just to name a few in the US. Then there are regions in London, Frankfurt, Dublin, Tokyo, Sydney, Sao Paulo. The list goes on, currently over 30 of them and constantly expanding. Now here's the brilliant part. Each of these regions is made up of multiple, isolated locations known as availability zones or AZs. An AZ is essentially one or more discrete data centers, each with its own redundant power, networking, and cooling. They're close enough to each other to have low latency connections, but far enough apart that a single disaster like a fire, a flood, or a major power outage is extremely unlikely to take out more than one AZ at the same time. This is the foundation of high availability. A US developer can, with a few clicks in the AWS console, deploy their application across multiple AZs within a single region, say Oregon. If one of those entire data centers goes offline for any reason, traffic is automatically rerouted to the healthy ones. The end user experiences no downtime. The application just keeps working. This level of resilience used to require an entire team of specialized and very expensive infrastructure engineers. Now it's the default best practice way of building on AWS. But that's just for resilience in one part of the world. Let's go back to our developer in Chicago whose app just went viral in Europe. What do? With AWS, the solution is breathtakingly simple. They can take the exact same architecture that's running in the US, and with a few configuration changes, deploy it to the Frankfurt region. Now, their German users are being served from servers in Germany. The latency drops from hundreds of milliseconds to just a few dozen. The user experience is suddenly fast, snappy, and responsive. They can do the same for their new users in Asia by deploying to the Tokyo region. In a single afternoon, a small startup team in the American Midwest can achieve a global presence with local performance that would have been the envy of a Fortune 500 company just 15 years ago. This isn't just a convenience, it's a complete paradigm shift. It allows American developers to think globally from day one. The market is no longer just the United States, the market is the entire planet. And it gets even better. For delivering static content, things like images, videos, CSS files, and JavaScript, AWS has another layer to its global network called Amazon CloudFront. CloudFront is a content delivery network, or CDN. Think of it as a global web of over 400 smaller, strategically placed data centers called edge locations. When a user in, say, South Africa requests a video from your application, CloudFront is smart enough to not pull that video all the way from your main server in Ohio. Instead, the first time it's requested, it pulls the video to the edge location in Johannesburg. Then, every subsequent user in that area gets the video delivered directly from Johannesburg. This is what allows you to watch a 4K movie on Netflix or Prime Video with no buffering. It's what allows complex websites to load in a fraction of a second, no matter where you are in the world. Developers can integrate this powerful CDN into their applications with minimal effort, instantly accelerating their websites and media for a global audience. This massive physical infrastructure does more than just provide speed and reach. It provides a level of disaster recovery that was previously unimaginable for anyone but governments and a few massive banks. The gold standard for critical applications is now a multi-region architecture. Imagine your primary operations are running out of the Northern Virginia region. You can set up a complete, mirrored standby version of your entire application in the Oregon region, on the other side of the country. Your data is continuously replicated between the two. If a catastrophic event, a hurricane, a massive earthquake, a widespread network failure, were to take the entire Northern Virginia region offline, an event that would cripple most businesses, you could fail over your entire operation to Oregon in a matter of minutes. Your global users would be rerouted automatically, and most would never even know there was a problem. This is the power of building on a platform that has poured hundreds of billions of dollars into a global, resilient, and interconnected physical network. For a developer learning AWS, they're not just learning how to code an application. They're learning how to wield this planetary scale machine. They're learning the principles of fault tolerance, disaster recovery, and global traffic management. These skills transform them from being just a software creator into a true architect of robust, scalable, and globally aware systems. They are learning how to build applications that don't just run, but applications that can survive. This is a profound shift in what it means to be a developer. The scope of a developer's concern used to end at the boundary of their code. Now, thanks to the accessibility of platforms like AWS, developers are empowered to think about the entire lifecycle and global footprint of their application. How do we serve our users in India with the lowest possible latency? What is our recovery plan if the entire US West Coast goes offline? These were questions once reserved for a chief technology officer or a VP of infrastructure. Today, they are questions that every developer building on the cloud is learning to answer. They are becoming more than just coders. They are becoming global engineers, capable of building systems that are not only intelligent, but also incredibly resilient and performant on a worldwide stage. And this elevation of the developer's role, this expansion of their capabilities, is a direct result of the immense physical foundation AWS has built. But this physical and digital infrastructure is just the platform. The real magic, the thing that ties it all together, is the culture of innovation that AWS has fostered. This culture isn't just a feel-good mission statement on a wall. It's a tangible operational mechanism that drives the entire platform forward. It's built on a principle Jeff Bezos famously called the Day One philosophy. The idea is that every day at Amazon should be treated like the first day of a startup. It's a mindset of being agile, experimental, and, above all, obsessively focused on the customer. For AWS, this isn't just a suggestion. It's the law of the land. And the most famous manifestation of this is their working backwards process. Unlike most tech companies that might develop a cool piece of technology and then go looking for a problem to solve with it, AWS does the exact opposite. They start with the customer. They write a press release for a new service and an FAQ document before a single line of code is ever written. If they can't articulate the customer benefit in a clear, compelling way in that press release, the project doesn't get greenlit. Think about that. They anchor the entire product development lifecycle, a process that will eventually consume millions of dollars and thousands of engineering hours, on a simple question. Does this solve a real, pressing problem for our customers? This is why the AWS Service Catalog looks the way it does. It's not a perfectly curated, minimalist set of tools. It's a sprawling, sometimes overlapping, and incredibly deep collection of solutions Because it's a direct reflection of a decade and a half of customer requests. When developers said, "Managing servers for our code is a pain, we just want to run functions," AWS didn't just try to make server management easier. They worked backwards from that pain point and created AWS Lambda, pioneering the entire serverless computing movement. When companies said, "We love relational databases, but we need the scale of the internet and can't be constrained by old guard licensing," AWS built Aurora. When the machine learning community said, "Training models is complex and expensive, and managing GPU clusters is a nightmare," they built Amazon SageMaker to abstract away that complexity. This customer-obsessed feedback loop creates a relentless, accelerating cycle of innovation. It's why AWS Re-Invent, their annual conference, isn't just a marketing event. It's a fire hose of new product announcements. They don't just announce one or two big things. They announce hundreds of new services and major feature updates every single year. This constant evolution is a double-edged sword for developers. On one hand, it's incredible. The toolkit you have at your disposal is constantly getting more powerful, more efficient, and more capable. On the other hand, it means that AWS isn't a static subject you can just learn once and be done with. It's not like learning a programming language that has a new version every few years. It's like trying to master a city that adds new neighborhoods and highway systems every single week. The skills you have today are valuable, but they have a half-life. To stay relevant, you have to keep learning. And this brings us to the core question, the reason you clicked on this video: why now? Why, in this specific moment, are so many developers in the United States making the decision to dive deep into the AWS ecosystem? It's because several massive industry-shaking trends have converged, and AWS is sitting right at the epicenter of all of them. First, we've crossed the tipping point. For years, the cloud was seen as something for startups and tech-forward companies. Legacy enterprises were hesitant, bogged down by their on-premise data centers and old ways of thinking. That era is over. The cloud is no longer the alternative. It is the default. From Fortune 500 banks to government agencies to healthcare providers, everyone is migrating. This has created a demand for cloud skills that has reached a critical mass. It's no longer a nice-to-have on a resume. It's becoming a must-have. Not knowing the fundamentals of cloud computing is starting to look like not knowing how to use version control. It's a foundational gap in a modern developer skill set, and the market is signaling that loud and clear with higher salaries and more opportunities for those who possess these skills. Second, the explosion of generative AI. This isn't just another tech trend. It's a paradigm shift on the scale of the internet or the mobile phone. And at the heart of this revolution is a desperate need for one thing: massive on-demand computational power. You cannot train or run a large language model on your laptop. You need fleets of specialized servers, high-speed networking, and a sophisticated software stack to manage it all. AWS is not just a participant in this race. It's a primary arms dealer. With services like Amazon Bedrock, which provides easy API access to a range of foundation models, and their custom-designed silicon like Trainium and Inferentia chips, optimized specifically for machine learning, they are providing the foundational infrastructure for the AI revolution. For a developer, learning AWS now means you're not just learning cloud. You're gaining a ticket to the most exciting and transformative field in technology. You're learning the platform where the future of AI is being built. And third, the economic imperative. In a climate of economic uncertainty, businesses become obsessed with efficiency, cost-cutting, and doing more with less. This is where a deep understanding of the cloud becomes a superpower. A developer who can just write code is valuable, but a developer who can write code and deploy it on a serverless architecture that scales to zero and only costs money when it's being used, that developer is invaluable. Someone who understands the nuances of AWS cost management, who knows when to use spot instances versus reserved instances, who can architect a system to leverage S3's different storage tiers, who can use the Cost Explorer to hunt down and eliminate waste, that person can directly save a company hundreds of thousands or even millions of dollars. In this economic environment, that skill isn't just about technology, it's about business survival. And companies are willing to pay a premium for it. So you have a perfect storm. A market that has reached a tipping point in cloud adoption, a technological revolution in AI that is completely dependent on cloud infrastructure, and an economic climate that puts a massive premium on cost efficiency. This is why so many developers are learning AWS right now. The incentives, career, technological, and financial, have never been more aligned. But let's be honest. Staring at the AWS console for the first time, with its list of over 200 services, is intimidating. It feels like an insurmountable mountain of acronyms and jargon. Where do you even begin? That feeling of being overwhelmed is normal. But here's the reframe. It's not a mountain you have to climb. It's a toolkit you get to use. You don't need to master every single tool in a master carpenter's workshop to build a beautiful table. You just need to know the essential ones and how they work together. The path forward is actually clearer than it looks. You start with the fundamentals, the holy trinity of cloud infrastructure: compute, storage, and networking. In AWS terms, that means EC2, S3, and VPC. Master those, and you've understood 80% of what makes the cloud work. From there, you can branch out. Get your AWS Certified Cloud Practitioner certification, not just to put it on your LinkedIn, but because the process of studying for it forces you to learn the breadth of the platform and the language of the cloud. It gives you a map of the city before you start exploring the neighborhoods. And then, the most important step of all, build something. Don't just watch tutorials. Don't just read documentation. Build a project. Deploy a personal website on S3. Create a simple serverless API using Lambda and API Gateway. Set up a CI/CD pipeline with Code Pipeline to automate your deployments. The theory will only take you so far. It's in the act of building, of troubleshooting a security group rule at 2 a.m., of figuring out why your Lambda function is timing out, that the real durable learning happens. Learning AWS in 2024 is about so much more than learning a vendor's product suite. It's about learning the fundamental principles of modern software delivery. It's about understanding scalability, fault tolerance, and global distribution, not as abstract academic concepts, but as practical tools at your fingertips. It is about future-proofing your career in an industry where the lines between writing code and managing the infrastructure that runs it are blurring into non-existence. The developers who thrive in the next decade will be the ones who can think across that entire stack. The world is being rebuilt on top of this digital foundation. Our economies, our entertainment, our very way of life is increasingly running on code that lives in the cloud. The question is no longer if you should learn it. The real question is, in a world being built on this new land, can you afford not to find your place in it?